6.2 notes, long division. Our goal for today is to divide polynomials using long division. So when I see a division problem, I have my 103 divided by 4. So I make this corner of a box, and I write the 103 in here, and I write the 4 outside because I'm dividing by 4, so that goes on the outside. Then I say, how many times does 4 go into 1? It can't. Okay, so how many times does 4 go into 10? Twice. And 2 times 4 is 8, so we write it down here. Then we can subtract. What's 10 minus 8? Okay, 4 is not going to be able to go into 2, so I bring down that 3. How many times does 4 go into 23? 5 times. What is 4 times 5? Subtract. 23 minus 20 is 3. There's nothing left to bring down, so I'm going to write that as a remainder. I'm going to write it as 3 out of 4 because I was dividing by 4. So my fraction there is 3/4. Give me like a 1 through 5. I remember long division. I did that on my own. I'm totally good with it. Sounds like it. Okay, so let's do these next ones then. Even though this is written a little bit differently, it's still division. 108 divided by 9. So I'm going to draw my corner of my box. On the inside I have 108 divided by 9. All right, how many times does 9 go into 1? It can't. So how many times does 9 go into 10? Once. What is 9 times 1? So we write it right here. We subtract. What's 10 minus 9? 1. Does 9 go into 1? No. So we have to bring down that 8. Does 9 go into 18? Twice. What is 9 times 2? 18. I subtract. This time I'm left with 0. There's no remainder. So far, so good? Let's try the next one. I saw some weird things written when I was walking around on this next one. 110 times, what is 9 to the negative first power?
1 over 9.
Yes, 1 over 9. So the problem I actually have here is 110 times 1 over 9. What is 110 times 110 times 1 divided by 9? Isn't this the same thing when I multiply fractions together that I multiply across the top, multiply across the bottom? I really just have 110 divided by 9 there. Because this is moving to the denominator, all this says is I have 110 times 1/9, or 110 divided by 9. Are we okay with how I got from here to here? This is just a division problem if you have something raised to the negative first power. It's just a new way of looking at it since we haven't really done much with negative exponents until 6.1. But this is no different than the other problems that you guys did way back in. When did you guys learn long division? Was it 4th grade, 5th grade? Probably around there, 4th? Okay. So I'm going to do this problem. 110 divided by 9. Can 9 go into 1? No. Can 9 go into 11? How many times? What is it 1 time into that? 1 times 9 is 9. Subtract. 11 minus 9 is 2. It's not going to be able to go into 2, so you're going to have to bring down that next one. How many times does 9 go into 20? Twice. What is 9 twice? 18. Subtract again. 20 minus 18 is 2. There's nothing left to bring down. So what's my remainder here? What's the extra that I have? 2 9s. All right, so we have 12 and 2 9ths is what we have left. All right, this one here. 1090 divided by 15. 15's not going to be able to go into 1. It's not going to be able to go into 10. How many times does 15 go into 109? 7 times. What is 7 times 15? What is it, 105? Subtract. We have a 4. Bring down the 0. How many times does 15 go into 40? Twice, which is 30. Subtract. We get 10. What's your remainder? Okay, so 10 15ths, but that reduces to 2/3. So we need to rewrite this as 72 and 2/3. So far, so good? Okay, we're going to go up to the one that doesn't have the remainder, because there is a way you can check your division. Does anyone know how you can use multiplication to check your division? Go ahead, Grant. Yeah. We're going to multiply those two numbers together. What is 12 times 9? 108. That's what we had started with, so we know our answer is correct. So far, so good? So we're going to go back through and check these other ones too. On this one, okay, to check it, we can do 25 3/4 times 4, and hopefully we'll get that 103 number. Now be careful when you type this in though, because you can't really type in 25 3/4, but what I can type in is 25 plus 3/4 in parentheses, because isn't that going to be 25 3/4? Okay, times that 4, and what should I get when I type this in? I should get 103. There we go. It worked. So that tells me that that is the correct answer. Yes, Blake?
And if you also, like for that one, you can do 25 times 4 and then just add the remainder.
That was my next step, yep. So on this one, the other way to check it is you can take the 25 times 4, which is 100, plus the 3 that was your remainder, equals the 103, which is what we had to get. Okay? Now you have to be careful with that method, because if I go over here, some people try to add 2, but your remainder was actually 10. So in this case, if I do 72 times 15, I can't see that, 72 times 15, I get 1080, plus the remainder was 10. You have to use the remainder, not the 2/3. Does that make sense? Not the 2 from the 2/3. If you were to multiply this, you could have done 72 plus 2/3 times the 15. That would also get you the 1090. Okay, so that 2/3 would work if you were doing the multiplication part of it, but not if you added the remainder in. Yes, Libby?
So if you're just doing where you add the remainder, you like ignore the fraction.
Yep. Yep. And that's the way we're going to do it once we get into the polynomials. Okay? So far, so good. All right. Then, Number 1, we actually are going to take a break from long division, and we are going to divide in actually a way that you guys already know. So let me take you back to some old school stuff that looks a little bit more familiar. You don't have to write this down, but I'm going to prove to you that you already know how to do this problem. If I have 4y equals 8y minus 10, how would I do this problem? Or, I'm sorry, that's supposed to be an x there. 4y equals 8x minus 10. And I said, solve for y, get y alone. What are you going to do, Blake?
Don't you plug 0 or 1 into x?
Nope, I just want to get y alone. Go ahead. I'm going to divide everything by 4. So I'm going to divide the right side by 4 and the left side and the right side. Probably should have it in order. So far, so good? Now, on the left side, I have y. What do I have on the right side? Blake, go ahead.
2x minus 10 over 4. Oh, well, which would be 5 over 2.
Okay, 5/2. Is that okay? The reason being, because when you divide, this is technically a polynomial. It's a binomial. It's 2 terms. Okay? And when we divide by, this is called a monomial. It's a single term. All you're doing is you're dividing each of those terms by that 4. Right? Raise your hand if this looks familiar to you. You could do that. Then you can do what we're going to do today. Because all we're doing is dividing by 4 plus a couple variables. Okay? So what we're going to do is, if you're dividing everything by 4 CDF, you're going to take the 20 c to the 4th d squared f over 4 CDF minus the middle term 16 CDF squared over 4 CDF plus the 4 CDF over 4 CDF. So you're just taking each of the terms and dividing by whatever it is you're dividing by. Each term gets divided by that term. So far, so good. Now this goes back to 6.1 because I cross off these two and I focus on that first one and I say, okay, I'm going to use my 6.1 knowledge. How do I simplify that fraction? What's 20 over 4 going to reduce to? 5. On top or bottom? Top, so 5. The C's, do you have more on top or bottom? So your answer will be on top. How many C's do you have left?
3.
So C to the 3rd on top. Your D's, do you have more D's on top or bottom? So your answer will be on top. And how many D's will you have left over? Just 1. How about the F's? Are there more F's on top or bottom?
Same. So we cancel.
They will cancel. So your F's cancel completely. So you have 5C to the 3rd, D to the 1st. Technically it's over 1. You don't have to write it over 1. No, it's just 5C to the 3rd, D to the 1st. Minus, let's look at that middle one. 16 over 4 reduces to just 4. C over C reduces to 1. We don't have to write anything in. D over D reduces to 1. F squared over F reduces to F on top or bottom? On top. Okay, plus 4 over 4 reduces to 1. C over C reduces to 1. D over D reduces to F over F reduces to everything reduces to 1. Okay, so my final answer here, is this in standard form? Is this first one have a higher degree than this one, which is a higher degree than this one? Yeah, this one has a degree of 4, degree of 1, degree of 0, so it's all in order. So my answer here is 5c to the 3rd d minus 4f plus 1. I'm going to go back up to number 2 from our review section. And when I go back up there, 108 divided by 9, my answer was 12. What I did was 12 times 9 gets me 108. So far, so good? So down here, I'm going to take my answer times 4 CDF, and hopefully I get that top number. Okay? That's the way I'm going to check this. So I'm taking 4 CDF, and I'm going to multiply by the 5C to the third D minus 4F plus 1 that I got as my answer, and we have to see if this equals that top number of this fraction. Now that's, again, something that we did in 6.1. So we have to distribute the 4 CDF to all 3 of these terms. So I'm going to go ahead and let you guys do that. So I unfreeze the screen. There we go. And what you should end up with is what you started with. Okay? So that just confirms that, yes, this, cool, I can put a nice little squiggly circle check. I checked it. I know that that's my final answer, and I'm confident in it because I checked my work. So far, so good? All right, now we're going to move to the scary part. Okay? Except I don't want you to think of it being scary. It's just a little overwhelming at first. Here's why. We're going to do long division now with polynomials. Okay? This is a much longer problem than what you're going to be expected to do on your homework. However, the reason why I made it a longer problem is because it's only an algorithm that you have to memorize. Okay? And a longer problem, you have to repeat the algorithm more times. I created a longer problem, so we had to continue to do the algorithm so that way it becomes more habit. The more you do this, the easier it's going to get, I promise. Okay? Your problems on your homework are going to be much shorter, even though you're going to have more of the problems. We will do 1 or 2 of those homework problems together once we do this problem on the notes. Sound good? Okay, so we have a division problem, because really this is 1 over x plus 3, right? Now, since this, what you're dividing by, is a binomial, we can no longer just write each term over a binomial because you wouldn't be able to simplify it. You can only simplify it here because we had a monomial. There's no adding or subtracting in there. When you have the adding and subtracting in there, you wouldn't be able to do anything with each of those fractions. So because of that, we have to resort to long division. When we do this long division problem, your box got a lot wider because it's a polynomial in there and not just a number. The first number goes in there. We have 3z to the 4th. Now actually, before I even continue writing, I want to double check first that this is in standard form, and second, that there's no terms missing. Okay? So this has a degree of 4. This has a degree of 3, 2, 1, 0. Luckily, there was nothing missing, so I can go and continue writing. However, if there wasn't if it went from 6z to the 3rd plus 3z, I would have to write in plus 0z squared because you would want a placeholder there. You'll see why in a little bit because we have to have like terms line up. And if you didn't have a placeholder there, your like terms wouldn't line up and things get messy. Okay, so you always want to make sure to put placeholders in if necessary. I'll show you on your homework what I mean by that because there's one on your homework where you'll have to have a placeholder. Yes, Blake?
So no matter what, as long as if you're missing one, you plug in 0z and then all like 0 and then the variable.
The term that's missing, yep. So you'll plug in a 0 whatever to the whatever that's missing. So minus 6z to the 3rd minus 9z squared plus 3z minus 6. On the outside, we have divided by z plus 3. I'm going to try to use multiple colors here to kind of see the difference of what I'm doing. Are we ready? So just as before, I said z goes into this first number how many times? Or z times what would give me as close to this as possible? No, we have a 1 here in front of this. So 1 times what would get you 3? 3, so we have to have a 3. Z times what would get you z to the 4th? Not z to the 4th, z to the 3rd. So we're going to have z to the 3rd first. Okay? Then what we did was we said whatever this number was up here, we multiplied by this out here. So we like to write it over here, otherwise sometimes we lose track of what it is we're doing. So we're going to take that 3z to the 3rd and multiply by the z plus 3. And we're going to write the answer underneath here. That answer is 3z to the 4th plus 9z to the 3rd. What did we do after we wrote the number underneath? If you look back to these, what did we do once we wrote the 9 there? You subtracted. Okay? So what we're going to do is we are going to take this polynomial and subtract it. It's important that you put it in parentheses, though, because you want that subtraction sign to apply to both terms. I came up with 3z to the 3rd because I wanted to get as close to 3z to the 4th as possible. And I know I'm going to be multiplying z by something. So I wanted that to be, has to be a 3, because I needed to get to 3. Z to the 3rd times z gets me z to the 4th. That's why I picked z to the 3rd. Just keep watching, because we're going to do it over and over again. We're going to take these same steps and have to keep redoing it. That's why we did it a long problem. Okay, so the subtraction sign distributes. So instead we're going to add a negative here and a negative here. Positive 3z to the 4th minus 3z to the 4th cancel. Negative 6z to the 3rd minus 9z to the 3rd is negative 15z to the 3rd. Keep bringing everything else down. Okay. The next one that we're going to look at is z times what gets me as close to as possible as negative 15z to the 3rd. 1 times what would get you negative 15? So it's minus 15. Z times what would get you z cubed? Z squared. So what I came up with was negative 15z squared times the z plus 3 that we were dividing by. Remember, multiply that out, we'll write the answer here. We have negative 15z to the 3rd minus 45z squared. Remember, from there, we subtract. So I'm going to put this in parentheses and subtract it. Distribute the subtraction sign. So this is going to become a positive, and that's going to become a positive. Now, negative 15 and a positive 15 go away. Negative 9 and a positive 45 combine to 36z squared. Notice the like terms line up. That's why if we needed a placeholder, we'd have to have one there. Carry down everything else that's left. Again, I know it might be a little overwhelming right now, but we're just going to keep going, and I promise you it will get easier. I'm going to change colors again. Z times what would get me 36z squared? 36z. So I'm going to write plus 36z up here, and I know then 36z times, I divided by z plus 3. So that's what I'm going to have. That's the multiplication problem I have to do. 36z times z is 36z squared. 36z times 3 is plus 108z. Once I have that answer, I have to subtract it. But nobody likes to subtract, because we want to distribute the negative sign. So I'm going to change it to adding a negative here and a negative here. Combine the like terms. 36z squared and a negative 36z squared are no more z squared terms. 3z minus 108z is negative 105z. Bring down that negative 6. We're almost there. All right, let's see. Z times what would get you negative 105z? Minus 105. So I'm going to take that negative 105 and multiply by z plus 3. I'm going to write my answer here. Negative 105z and negative 315. Now, what I did with that was I subtracted it. So I put parentheses around it and I'm going to subtract. You have to distribute that negative sign to both terms on the inside, which actually turn them into positives. Negative 105z and positive 105z cancel. Negative 6 and a positive 315 combine to be 309. Z can't multiply to anything to get to 309. Once you have it down to a single number, that is your remainder. How did we write the remainder, though, on the front page? Blake?
You would put the remainder over what you were dividing by.
Yes, we would put the remainder over what we were dividing by. So it would be 309 over z plus 3. So when we write in that last step, let me find another color here. I'm going to write it plus 309 over z plus 3. Now remember, we've done the long division. When we were checking it before, so looking at this one here, okay, we took 4 and multiplied by 25 and then added in that remainder of the 3. Remember we did that? So here I'm going to take my answer, so this thing here, times what I divided by, then I'll add in my remainder. So we're going to write this out. We're going to have to multiply z plus 3 times the 3z cubed minus 15z squared plus 36z minus 105. I'm not going to write the fraction part because that's what I'm going to add in later as my remainder. So plus the 309, which was your remainder. Are we okay with how I wrote that? So you took your answer times by what you divided by, and then we'll add in the remainder, that 309. I'm not going to worry about writing that as a fraction because no one wants to deal with the fraction part. So far, so good? Okay, well, here comes our 6.1 stuff on simplifying with multiplying. So I'm going to distribute my z to all these terms. And I'm going to get 3z to the 4th minus 15z cubed plus 36z squared minus 105z. And then I'm going to go back. And you could do the seashell method. You could do the box method. It does not matter here. I'm going to distribute my 3 to all 4 terms plus 9z to the 3rd minus 45z squared plus 108z minus 315. And then I still have that plus 309 there at the end. My last step tells me all I have to do is combine like terms. And hopefully what I get is what I started with. So 3z to the fourth, there's no other like terms. That's going to go out front. The negative 15z to the third and 9z to the third is going to be minus 6z to the third. Took care of those. 36z squared and negative 45z squared minus 9z squared. Took care of those. Negative 105z and a positive 108z plus 3z. Took care of those. These last two, negative 315 and 309 minus 6. This is the same as what I started with. Zoom out. Super long problem. There we go. 3z to the fourth minus 6z to the third minus 9z squared plus 3z minus 6. Since that was correct, I'm confident that this right here is my answer. I verified that that is my answer to my division problem. Deep breath. We did it. You do not have to do problems that are this long. We did them that many times because I wanted you to see the algorithm over and over and over again. Okay? Let's go to your homework, and I'll do numbers 1 and 2 with you. Actually, before we even start on that homework, let me show you. There is one problem on here that you need a placeholder on. Can anyone find it? There is a problem on here where it doesn't go in order from like 3, 2, 1, 0, 4, 3, 2, 1, 0. Grant, do you have it? It is number 8. When you look at number 8, you probably want to rewrite this as x cubed minus 0x squared minus 13x minus 12 times that x minus 4 to the negative first power. There are also 2 problems on here that you don't have to do long division on. Can anyone tell me one of the problems that you don't have to do long division on? Grant, go ahead. 7, you do not have to do long division. It's a monomial that you're dividing by. You don't have to do long division. There's another one that you don't have to do long division. Nora? Number 3. Number 3 is the other one that long division is not necessary. You're dividing by a monomial. You do not have to do long division when you're dividing by a monomial. Do you see the difference? Okay, let's try number 1 together. Set it up first. So I'm going to hit pause up here. You're going to set it up and see if your setup matches mine. Does yours look like this? Give me 1 through 5. I can do the setup part. Okay, now, x times what will give me x squared? So we're going to write an x up here. What is my math problem over here I have to do over off to the side? X times x plus 5. Good. Once I figure out what that is, I'm going to write it under here. X times x is x squared. X times 5 is 5x. That's what I'm going to have to subtract. Subtract it. I'll pause mine so that you can't see, and we'll see if you're able to get it. Does yours look like mine? Raise your hand if you were able to do that. Coolio. All right. What's my next number that's going to go up here? Negative 8. X times negative 8 is going to give me my negative 8x that I need. So I'm going to have to put a minus 8 up here. What's my problem I'm going to write over here then? Yes, negative 8 times the x plus 5. Let's figure out what that becomes and do your next step. Does your next step match mine? What's the remainder this time? 0. So what's my actual final answer here? Just the x minus 8. That's my answer. Okay? What's my math problem that I have to do in order to check this answer? X plus 5 times what? Times the x minus 8. Well, that's not that bad of a multiplication problem, is it? That's just foiling. First, outside, inside, last. Go ahead and do the multiplication. That's what I got. So since this matches up here, we're confident, and we can put a little check mark here saying, yes, I checked my answer. I know x minus 8 is the right answer, and I did it correctly. Does that make sense? Do we feel like we could try number 2 on our own?
Yes.
All right, let's go for it. Okay, so if you did all of number 2, this is what it should look like. And I'll leave that up there for you guys.